The FIDO Alliance launched in 2013 with a very specific, aggressive mission to eliminate the world's reliance on passwords. Today, with over 250 members, including Apple, Google, and Microsoft, they are telling us they have finally achieved it through a technology called passkeys. We are being sold a vision of the future where logging in is seamless, phishing is impossible, and our digital lives are impenetrable. But the tech giants are leaving out a crucial detail about this transition. By adopting mainstream passkeys, you are trading the risk of 100 small password leaks for one catastrophic single point of failure. You are handing the master keys to your digital identity over to a small handful of massive corporations. Today, we are unpacking this ticking bomb of passkeys, the hidden dangers of vendor lock-in, and the alternative solutions like decentralized identity and AI-augmented access management that could actually keep us secure without stripping away our control.
The marketing push for passkeys is relentless right now. And on the surface, the core technology makes a lot of sense because passwords are a fundamentally broken system. For decades, we have relied on a shared secret model. You know the password, the website server knows the password, and if anyone intercepts that secret, the system fails. The FIDO Alliance, working alongside the World Wide Web Consortium to develop the Web Auth N standard, built passkeys on public key cryptography to solve that exact vulnerability.
Break down that cryptography for a non-technical user. How does a passkey actually function differently from just a very complex auto-generated password?
Think of public key cryptography like a physical mailbox sitting on the street. The website gets your public key, which acts like the mail slot. Anyone can slide a message in, but only you hold the private key, which is the physical metal key required to open the box and read the contents. With a passkey, that private key is generated on your device and is supposed to stay on your device. When you log in, the website sends a cryptographic challenge. Your device uses your biometric data like a fingerprint or a face scan to unlock the private key locally, sign the challenge, and send the proof back. The website never sees the private key. Hackers cannot steal what is not on the server.
That localized security model sounds bulletproof in theory. It prevents the mass data breaches we see constantly, where millions of passwords are dumped on the dark web. The problem arises in how these massive platform providers have chosen to implement the storage and synchronization of those private keys. That is the trap.
The FIDO specification allows for hardware security keys, which remain entirely under your control. But Apple, Google, and Microsoft know that ordinary users will lose physical keys. So they pushed what they call a synced passkey. When you create a passkey on a modern smartphone, it defaults to saving inside the Apple iCloud Keychain or the Google Password Manager. The platform syncs your private keys across all your devices in their ecosystem. It feels seamless, but it fundamentally shifts the power dynamic. Your device is no longer the sole keeper of the key. The cloud provider manages the synchronization and the backup,
which introduces a terrifying vulnerability. If a user relies entirely on Google Password Manager for their synced passkeys, their entire digital existence is tied to the standing of that single Google account. We have seen automated systems flag accounts for alleged terms of service violations. Sometimes it's a misunderstanding, sometimes it is a mistaken algorithm. If that main account gets suspended, the user does not just lose access to email or cloud storage. They lose the cryptographic keys to their bank, their mortgage portal, their healthcare provider, and their work tools. Everything vaporizes.
It is a textbook single point of failure. The system is intentionally designed to prevent users from easily exporting or backing up those passkeys independently. The stated reason is security, ensuring the keys cannot be intercepted. The practical result is absolute dependence on the provider. You have traded the distributed risk of using different passwords across different services for centralized risk. If Apple locks an Apple ID because of a disputed credit card charge, that user is locked out of their entire life until the dispute is resolved. That is not a resilient security posture. That is fragility.
That dynamic looks a lot less like a security feature and a lot more like a calculated business strategy. We need to examine the vendor lock-in aspect. The tech industry talks about a universal standard, but the actual user experience of moving a passkey across different ecosystems is jarring. The walled garden effect is severe. If you create a passkey on an iPhone, it propagates automatically to your iPad and your Mac. The login process takes less than a second, but try using that same iOS-generated passkey to log into a service on a Windows computer or an Android tablet. The seamless experience breaks down immediately. You are usually prompted to scan a QR code with your phone camera, relying on a Bluetooth proximity check. It often fails, it requires multiple steps, and it feels like a beta test rather than a polished global standard. The friction is intentional.
The financial incentive for these corporations is to keep users entirely within their hardware and software loops. The harder they make it to use your digital identity outside of their specific brand, the less likely you are to buy a competitor's device next time. They're using the guise of cybersecurity to cement market dominance. The FIDO Alliance is actively working on new protocols to allow easier credential exchange between different password managers. But the major players have historically dragged their feet on interoperability that threatens their ecosystem retention. Your digital identity is the ultimate anchor. If your keys only work smoothly on one operating system, you are essentially held hostage by that operating system. This brings us to a fundamental philosophical question about the internet. Who should own your identity? Currently, the platform providers own it, and you are just renting access to it through their hardware.
If mainstream passkeys represent a flawed, centralized transition, we need to look at the actual solutions. The direct antidote to centralized corporate control is decentralized architecture. The World Wide Web Consortium has been developing standards for decentralized identifiers, commonly referred to as DIDs. Walk through how a DID shifts the balance of power back to the user.
A decentralized identifier separates your identity from any single corporate issuer. Right now, your identity is fragmented. You have a Google identity, a Microsoft identity, a state-issued driver's license, and an employer ID. A DID provides a single, verifiable digital identity that you create and control. It's stored in a personal digital wallet on your device, often secured by a decentralized ledger or blockchain, rather than sitting on a server in a massive data center. This concept is called self-sovereign identity.
The distinction there is crucial. If the data lives in a wallet on my device, authenticated by an immutable ledger, no single company has the administrative rights to revoke my existence. How does a user actually interact with a website using a DID compared to a passkey?
It relies on something called verifiable credentials. When you want to access a restricted service, let us say a platform that requires you to be over 18, you do not need to provide your full name, your home address, and your date of birth. You use your device's biometric scanner to unlock your DID wallet, and the wallet generates a cryptographic proof that you meet the age requirement. You hand over just that specific attestation. The website verifies the proof against a decentralized ledger. You maintain absolute privacy, you expose zero unnecessary data, and you dictate the terms of the interaction. It moves the internet from a model of, please grant me access, to, here is the proof you request.
That solves the centralization and privacy problems, but it does not fully address the static nature of the authentication itself. A passkey or a DID wallet unlocks the door at the moment of entry. It assumes that once the door is open, the person sitting at the keyboard remains the authorized user. If a laptop is snatched from a coffee shop table while unlocked, or if malicious software hijacks a session token after the initial login, the initial cryptographic check becomes worthless.
That static checkpoint is a major blind spot in current security frameworks. To fix it, the security industry is moving toward AI-augmented identity and access management. AIAAM changes authentication from a one-time event into a continuous invisible process. Instead of just checking a key at the door, an artificial intelligence system acts as a continuous monitor analyzing behavioral biometrics.
Behavioral biometrics involves tracking the physical habits of the user rather than just scanning a fingerprint. It builds a baseline of how a person operates their machine.
The AI monitors your typing cadence, the speed and trajectory of your mouse movements, the typical times of day you log in, and the network locations you frequent. Every user has a unique behavioral signature. If a session is initiated with a valid passkey, but an hour later the mouse movements become erratic, the typing speed doubles, and the network routing shifts to an unfamiliar overseas IP address, the AI flags the anomaly instantly. The system does not just watch passively. It takes action.
It initiates step-up authentication. The system can freeze the session and demand immediate re-verification, like a fresh facial scan or a hardware key tap before allowing the transaction to proceed.
It provides active defense against session hijacking and device theft. Combining a self-sovereign decentralized identifier with continuous AI-augmented monitoring creates a security posture that is light years ahead of what mainstream synced passkeys offer today. You get the cryptographic strength of a passkey, the independence of a decentralized wallet, and the active protection of an adaptive AI guard. The technology to build this exists right now. It is a matter of pushing the industry to adopt standards that benefit the user rather than the platform provider.
Passkeys are undoubtedly a step up from reusing a weak password across 50 different websites. But treating them as the final destination is a mistake. The current implementation pushes us further into a corner of corporate dependence, wrapping vendor lock-in in a veneer of cybersecurity. We have to view synced passkeys as a temporary bridge. The real destination must be a digital landscape where individuals hold sovereign control over their cryptographic identities, backed by intelligent systems that protect us continuously. If you found this breakdown of digital identity valuable, send this episode to a colleague who needs to hear it.